from the waiting room. So, hello, everyone, and welcome. Sorry I'm a minute or two late today, but I am super excited about our speaker. Andrew's back. He gave our most watched webinar last season, and it continues to get great traction on our YouTube channel. And today we have him talking about one of the topics I always love to hear him talk about, sand bedding, anaerobic digestion, and Andrew really made his name originally as a sand separation guy in managing it for dairy manure. But with anaerobic digestion, it's even more important. So, really excited to have Andrew back. Thank you so much for joining us. And with that, he really is the expert on this topic. So, take great notes, ask great questions throughout, and we'll make sure to get the hard ones to him so he gets to answer them. All right,
Sounds
thanks, Andrew.
good. Sounds good, Daniel. And thank you very much. Thank you very much for having me back. It was very enjoyable last time, and I'm super interested and excited to just kind of keep it going here. And I also want to say thank you, Daniel, for posting and advertising this event, posting a photo of me from 2014, so everybody can see what I looked like, kind of like in a time machine. So we'll get you a new picture for the next topic.
Oh,
So.
I thought you liked that. I still use my 2012 photo.
That'll work. So again, thank you, and thank you everybody who's joining us today. And so, just a little bit more about me and sand bedding. I first got familiar and associated with sand bedding in 1992. When I went to graduate school at Michigan State University, and believe it or not, in 1992, the Ag Experiment Station reached out to the dairy producers in the state and said, "We're gonna give some money to extension." The legislature said, "We're going to give some money to extension, but can you guys coalesce around an idea or just a topic that uh, that we can donate or give money towards to an ag engineering department?" And so, believe it or not, of all the things that dairy producers could think about, were the issues that they were dealing with in the day. In 1992, it wasn't breeding, it wasn't milk cows, it wasn't necessarily freestall design, but it was sand bedding. The dairy producers of Michigan in 1992, what they wanted was a solution to how to handle sand-laden manure, because sand bedding had just come on the scene. The term cow comfort had just come on the scene, and really the two go hand in hand. So fast forward ahead, 30 years or so, and boy, we've come a long way. Now we're sand bedding has become more or less passé, and we're looking at how do we integrate sand bedding with anaerobic digesters, and that's really what we're going to talk about today. Uh, just gonna have a little trouble here getting slides advanced. There we go. So, you know, I'm a very mechanical person, looking at things and shafts, bearings, motors, pumps, pipes, things that I can see and touch and feel, and just kind of the more I can see them, touch and feel them, the more I understand them. And so, this whole idea of does manure produce methane? There's bugs and there's biochemistry, all this stuff going on. What's really going on there? Well, like most of the things that I've learned, I learned from a dairy farmer in Pennsylvania once upon a time, because we were alongside the bank of a manure storage, and it was just bubbling. There was just a coat of bubbles across the top. And he said the thing that what the four most common words that rural youth say before they die, and that is, "Hey guys, watch this." And what he did was he dropped a piece of paper, a lit piece of paper, on that manure storage, and that wall of flames burned across that pond, like you wouldn't believe. And those the photo doesn't really do it justice in that those flames were probably about 20 feet high. And so I was a believer after that manure really does produce methane gas, and certainly nobody should try this at home. So, like I said, we've come a long way. And putting sand bedding aside, let's just talk about anaerobic digestion. And anaerobic digestion has really, really gained in popularity. And there's really been a number of reasons why. One is the gas markets are surely more lucrative. It is, I mean, things are kind of tough right now, but things have gotten much better, so, financially selling renewable natural gas as opposed to making electricity. That's one reason. Another reason is we're seeing more and more. I'll say almost all the plants, the digester plants we deal with these days, they are design, build, own, and operated by developers or investors. And really this presentation is for everybody involved in anaerobic digestion, but really this presentation is geared towards those people because they're designing them, they're building them, they're owning them, and they are operating. They are really the customer. They are really the client. And when those people came on the scene, a lot of them came over from the oil and gas side, and they were specialists in gas handling, and those types of things. And they brought with them a bit more of what I would call more of an industrial mindset. Whereas really the early variations of anaerobic digestion, they were always handled by the producer, right? And so meanwhile we have a dairy producer who's milking a couple thousand cows, and they're growing crops and milking cows, breeding cows, pulling calves, feeding cows, you know. And this anaerobic digester was just another thing. And it was just another, they already had a full-time job. And so when anything was going to get the short shrift, it was going to be the anaerobic digester. Don't get me wrong, dairy producers are fantastically capable, but to run an anaerobic digester is just a bit outside of the core competency. And then the last thing, we're going to dig into this a bunch, and that is there is more of a systems approach to anaerobic digestion. And I'm going to tell you a little bit more about what my view of a systems approach. But more and more people are taking a systems approach, but it's probably an area where we need to emphasize more. So, I look at this as your typical product adoption curve, right? So if we on the y-axis, if we were to say operating systems, on the x-axis, call it time, elapsed time. So, as far as anaerobic digestion systems, the first step we have is we have the innovators, right? And the innovators are people who paid too much money for something that didn't work. And there were a lot of people in that boat. Then you have the early adopters. They paid too much money for something that worked like most of the time. And so then, a product becomes accepted. And boy, after that, the ankle of the curve, we're working our way up towards the knee. The slope's real steep. More and more systems are being installed. This is kind of where we are, and we need to keep this going. So maybe in 2018 we were there, in 2040, maybe we're here, but everything in between, we're somewhere past the ankle. But anyway, so this is what we're looking at. We're trying to, how do we increase adoption of anaerobic digestion? So one of the things that comes up all the time is, one of the ways of increasing adoption of anaerobic digestion is to ensure that all of the producers who who um, who have feedstock, in this case manure, have their manure can go into anaerobic digestion systems. And for a long time, sand bedding was excluded, and so or farms that use sand bedding were excluded. And so it really gets to be a pretty daunting task when you think about the fact that for dairy cows bedded on sand, we're looking at about 50 pounds of sand per cow per day. And this ends up being about anywhere from 25 to 30% of the manure mass. And so this becomes an enormous amount of material that's going into the manure, and an enormous amount of material that's really detrimental when it comes to an anaerobic digestion tanks or any kind of enclosed vessel, or really any type of vessel, container, pump, pipe not properly designed for sand. So again, what we're going to talk about today is how to be successful with sand bedding and anaerobic digestion. The first is going to be the systems approach. The second is we're going to review sand manure separation systems. It's not going to be a commercial or an endorsement of any particular kind of system, but I'm going to kind of give you a sense for the landscape of really what is working out there. I'm going to talk about bypass sand because there's always going to be bypass sand. Nothing is 100% efficient. And then we're going to talk about the part that is going hand in hand with the systems approach. It's the part that oftentimes people forget about, and that is the people piece, people, contracts, and relationships. All these things go into making a successful sand system. So as far as the systems approach, so anybody who is over the age of 50 would remember the Saturday Night Live skit, the Olympia restaurant, And if you don't know the Olympia restaurant, you really should go YouTube Olympia restaurant. And for you younger people, it's where the term cheeseburger came from. And so people go into the restaurant and all you can order is a cheeseburger and Pepsi and chips. Nothing else. That's all they see. That's all they know is cheeseburgers, chips, and Pepsi. The traditional view of anaerobic digesters, and particularly developers and system suppliers, is kind of like the Olympia version of the same, in that the only thing they see as the system as tanks, 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 tanks. That's all they see. Tanks, tanks, tanks is the system start to finish. But it's not. The anaerobic digestion system is much, much more than that. And it's a bit daunting on how much more it really is. So when I look at a dairy system, I look at a bunch of different things. So this is a quote unquote a small, call it 2,500, 3,500 cow dairy. And so these are all the things that go into the dairy system. We have crop production, crop storage, we have housing, we're milking cows, we're processing dry cows. We've got runoff, right? Because we've got concrete pads where feed's being stored. Um, we have clean stormwater runoff. We have just manure management, getting the manure out of the barns, and then we have an anaerobic digester here circled in red. And so again, the traditional view of anaerobic digestion would be that's it. That's all we see is the tanks in that circle. But the boundaries of the system, so for the engineers in the crowd, when we talk about doing calculations or modeling things, we always talk about first thing you do is define the boundaries of the system. And the boundaries of an anaerobic digester system are it's the property, it's everything. It's the entire dairy operation because it all affects the anaerobic digester. And particularly today with sand bedding, it's about talking about the housing and milking cows and the environment that they are living in. And the funny thing is, if you ask a dairy producer, how important is the anaerobic digester as part of their system, you'll be lucky if it's number 100, because the most important thing to them is milking cows, breeding cows, keeping cows healthy. Anaerobic digester is an afterthought of all afterthoughts. So the first thing we need to do is we need to start thinking about anaerobic digestion as a system with the boundaries of that system going out to the expanses and extents of the dairy property. All these things are part of the anaerobic digestion system. And I'm going to give you an example of what that might be. So for instance, when milking cows takes a lot of water, and that's not to be viewed as a negative. Milk is a perishable good, and cows are mothers. We want to have good, healthy food, and we want to have healthy mothers. And for the sake of sanitation and cooling, we need to use water, whether that is cleaning equipment, or whether it's cleaning pen surfaces where cows are, or whether it's using sprinklers to cool the cow's temperature so that they're not so stressed. So we're putting water into there's lots of water going into these systems that needs to be accounted for in anaerobic digestion system. So the other part of the system included in this system is the bedding. And so we need, when we're planning for anaerobic digestion systems, we need to be planning for what the bedding is, what the cows are sleeping on, because it does have a dramatic impact on the performance of the digester. And then we have things like manure conveyance, because whether you vacuum, whether you scrape, or flush, or whether you flush flume, all these things have an impact. But again, we're focusing more on the sand bedding piece, because a digestion system set up for sand bedding is different than a digestion system set up for, say, organic fibers. So the other part, and really important part to remember, oftentimes whenever a digester fails, everybody wants to blame sand bedding. It's kind of like whenever there's a house fire, everybody wants to blame the electrician when the plumber has a torch too. You know, and so we have to remember that grit killed digesters long before or grit and sand killed digesters long before sand bedding became the talk of the town. And there's lots of reasons why. And part of it's because, just starting with dairy rations. Rations contain a surprisingly high amount of grit or dirt that just comes in from the field or scraped up on concrete, go right on down the line. And this material has a tendency to settle. So this is a pretty big lift, in that, again, grit killed digesters before anybody even dreamed of using 50 pounds per cow per sand per day of bedding. So let's talk a bit about sand manure separation systems. And so we've got a couple things working in our favor. And these are some of the things that we learned really early on when we started researching sand and manure. Was, well, geez, what are the physical properties of the bedding sand that farms are using? What's the quantity of sand that's being used? And so, and just some of the general characteristics of sand. Well, one of the things that we found was that sand, and some of you who are soil scientists and maybe better engineers than me just said, well, geez, no kidding, sand is 2.5 times more dense than manure. Well, that's a good thing, right? If we're looking to separate by density and gravity. The second thing is, the sands that are often used for bedding, they tend to be a coarser textured sand. And these coarser textured sands, these large dense particles, they have a tendency to want to settle. And so how can we use those two characteristics, the high density differential and the larger, relatively speaking, size particles, to do separation? It just so happens that for the engineers in the crowd, Stokes' law really describes this quite well, in that when we have a large dense particle, uh, its mass and its negative buoyancy can overcome the viscous drag, right? So this is the viscosity of the manure. This is Adam Bloom. You have a question? All right. Adam Bloom doesn't have a question. So basically, what we want to do is we want to create an environment where we can take advantage of gravity settling to produce a sand product that's not going to go into our digester, but then also, if it's bonus, if they can be clean enough, we can recycle the sand. So there's a couple ways of handling sand-laden manure, and the first is just to separate it um, mechanically, and that is an option. And usually it's done with some kind of a mining duty equipment, and I'm going to explain those systems a bit more, or to separate it passively. And I kind of use passively in quotation marks, because of the fact, if you have a sand settling lane that's using gravity to settle sand out down a long concrete lane, there's really nothing besides the actual settling aspect of it, there's really nothing passive because you end up having to run a big payloader up and down that lane to collect sand. Not a bad system, but it is what it is. So we have mechanical systems, and then we have passive systems, and then we also have hope, and hope isn't really a good idea when to pass sand into an anaerobic digester because of the fact we have a 20, 30, 40, $50 million investment that we just cannot take any chances in passing that material on to the tanks. So what sand capture can reasonably be expected? Recognizing again that we are going to bypass sand. And so each of these systems, whether it's a mechanical system or whether it's a passive system, you know, uh, we can do upwards 95% and higher. In fact, once you start getting below 95%, the amount of sand bypass becomes quite high. And we're going to go through that episode just to, what sand bypass, magnitude of sand bypass. And that's a good question is what happens to the bypass sand? Because it's got to go somewhere. It's really got to go somewhere. And excuse me, if it goes in, it really is going to either come out or it's going to be settled. And that is a really important thing to remember in that just because you bypass sand doesn't mean it's all going to settle out in the tanks. Because thinking back to our Stokes Law example, there is some viscosity in that manure and that in the digester, and some of that material will stay suspended. So just to look at the magnitude of bypass sand. So if we're looking at 50 pounds of sand per cow per day, that's a 2% bypass. Let's just say it's 5 pounds of or 1 pound of sand per cow per day. 1,000 cows, 130 pounds per cubic foot. You're looking at about 8 cubic feet per day, 3,000 cubic feet per year. It just starts to add up. And so, that would be a best case scenario, say 98% recovery in 1,000 cows. How many digesters out there do you know that are operating on 1,000 cows? Everybody's probably thinking not too many. So, we're looking at more like 5,000 cows or 7,500 cows. So the numbers get really big really fast. A little bit of sand goes a long, long way. So now taking the same and just looking at it for 5,000 cows per year. Now we're at 40 cubic feet per day. I just converted over to here to yards. 540 yards per year. How much does a triaxle dump truck hold? 10 to 15 yards. How many triaxle dump truck loads is that? 110,000 gallons. A little bit of sand really goes a long way. And so we have to do everything we can to get as much out as possible. Remembering again that not only are we adding 50 pounds per cow, 50 pounds of sand per cow per day, but that manure is carrying grit as well, just from field dirt and right on down the line. So the other thing that we see a lot is when digesters are opened up is, it's not just Adam Bloom. You have a question? I guess not. Uh, so we need to be planning. We need, in addition to sand bypass, we also get organic matter bypass because, again, for our engineers in the crowd, if you're thinking about Stokes' law, a small dense particle and a large less dense particle really want to behave the same and settle. So when you go into a digester that's being opened up, you kind of see what looks like almost like sand chowder. It's a mixture of organic matter and sand. That is everything that wants to settle together, everything that has the same settling characteristics. Not much to say here other than really just to illustrate that it's usually when you get down around this 100 mesh range that where you have corn kernels and sand grains having roughly the same settling or scouring characteristics. Going to talk a bit more about scouring, settling, and scour here in a bit. But just the most important thing to remember is some sand and some organic matter want to act the same. So we talked about some of the effects of dilution, And this is not quite, this is related to sand separation, but not related to sand separation. But nevertheless is an important part to kind of get across. So if we look at the effluent source being just raw as excreted manure, it's being passed at, say, from the cows at about 12% TS. And we're going to add parlor water or cooling water or any whatever other kind of water that's fresh water that's being used on the dairy. And so now we're taking that solids content from 12 to 6. Okay. And then if we go into a sand separation system, well, we're gonna add some additional water to rinse the sand, not quite so much, and we're gonna push the solids content even lower. So this would be the resulting total solids going to going to the digester. Now, we're going to use this water in a beneficial manner in order to separate sand from manure. But a lot of times developers will come to us and say, well, how do I raise the total solids going into my digester? Well, it's really simple. It's all of what comes in goes out. What goes in goes out type of deal. And so if you want to have less water in your digestate, put less water into your digester. But now in some cases it's really not possible, right? Because the parlor water has manure in it because it's probably been used to flush the decks and things like that. And so we're going to use that water in a beneficial manner in a sand separation system to help make clean sand. So the keys to a successful sand separation system, just some of the keys to a successful sand separation system, and this doesn't matter whether it's a mechanical system or a passive sandling system. It's really all the same because it's all a settling process. And so the first is dilution. We have to take that manure that's at 12% as excreted, and we need to dilute it down. We need to break the viscosity so that those sand grains want to settle. The second is we need to use the proper type of sand. And so if I'm a digester developer and I am writing a contract, I am going to be specifying what size sand I expect you to use. Because if I can specify the kind of sand that you're going to use, I have a better idea of what kind of separation system to have, and I have a better idea of what your recovery is going to be, and I have a better idea of what the nature of the bypass sand is going to be. This is really one of the easiest things because the type of sand that tends to be preferred for bedding is a concrete sand. It's an ASTM C33 concrete sand. People say, I can't get concrete sand. Baloney. If you have concrete on the dairy, you can get concrete sand because concrete sand is an ingredient in concrete. Concrete sand is the aggregate that's used to help concrete reach its designed compressive strength. The last part, I shouldn't say the last part, the next part of a successful system is the proper management. And this goes for any system, any aspect of a farm in that you have to have the proper management. You're not going to take this suite of equipment, put it in operation, turn the key, flip the switch, and walk away. You need to have dedicated people, dedicated, trained people or hired people that are going to run the system. And so as far as which one is most overlooked, I'm going to say that probably proper management and the people aspect, because for some reason, everybody loves to work in a milking parlor because it's lots of shiny, clean stainless steel. But when it comes to the manure system, it's kind of like it's not quite as cool and chic as working around all the cows and stainless. And so we need to have a committed, diligent effort to managing these systems.
Hey, Andrew, I hate to interrupt you, but quick
Yep.
question. Over in Northeast Iowa, some people like to use river sand. Could you comment on why maybe that one's not preferred and why we prefer concrete sand?
So yeah, happy to do that. So Dan, river sand can mean lots of different things because I've seen river sand be just the purest I've seen a natural river sand mimic concrete sand almost exactly. I've also seen river sand be like dust. And this is really a function of Mother Nature doing Mother Nature things in that, it's just where the glacier or the water put that material down on the ground. So I'm always concerned when people use these colloquial terms for sand, whether it's river sand, blow sand, torpedo sand, all these local terms, because they really mean a lot of different things. Now, I'm going to say that perhaps in your particular reference, you're thinking of a river sand that's maybe really, really fine. So my suggestion in those cases would be to acknowledge the fact that that sand is probably good and probably really, really inexpensive. But for the sake of digester health, I would be doing everything I could to convince that producer to go with a concrete sand or a specification sand because that way you can ensure, understanding that with that sand you're also with the specification concrete sand you're going to capture more and that sand's going to be cleaner and so that's what I would do. I It's very reasonable to make a case with a sand separation system how switching to a concrete sand is a really good business decision. On top of that, the concrete sand tends to be a bit coarser textured, and so it drains better. And the experts seem to think that it's a bit of a better bedding than the finer sand. So great, great, great question, and a question that can take a lot of different twists and turns. So I mentioned in some of my opening comments about how water is used all over on dairy farms. Again, not being wasteful. It's just it's cows. We want to take good care of cows and the milk. And so it's a matter of using that water in the right place. In other words, we want to take that water, and here we have a sand separation system where the manure is going into a sand separation system and then into a solid separation system. And we're using a solid separator paired with a sand separator to make dilution water to then dilute the sand and manure. And so a large portion of the water that we're using is water going around and around in a circle. Separate the sand, separate the solids, the liquids go back into the sand separator. But you can only do that so many times before the water just isn't wet anymore. It's like washing your hands with the same water over and over and over again. Eventually, you end up with enough dissolved solids that just the water's just not wet anymore. And so here's where we want to say, hey, let's use that parlor water very strategically. Strategically meaning use it so that it gets into the sand separation process at the sand separation process, as opposed to being bypassed around the sand separation process going directly to an anaerobic digester. Because remember, the parlor water, it's kind of like the cleanest dirty water on the farm. Like if you're flushing a holding pen with say plate cooler water, that water might have only touched manure once or twice before, and so I wouldn't quite call it's definitely not gray water anymore, but it's not a water that's very, very heavily laden with manure. Maybe a manure that's maybe around 1 or 2% maximum. So water that really makes for a good dilutant, because remember, we want to dilute that very viscous sand laden manure so the sand settles. So how do we go about comparing these systems? And I mentioned that I'm not going to give necessarily endorsement for one over the other because they both work. People are using both systems all day, every day with really a great success. When you talk about mechanical systems, usually it's a mining based system similar to what you'd have in a sand and gravel pit. Passive systems would rely strictly on gravity to settle out the sand. And instead of using mining duty equipment to collect the settled sand, you'd be using payloaders to collect the sand. With mechanical systems, it's a bit of a more controlled separation because we're adding manure, sand laden manure in at a controlled rate, and we're getting sand laden or clean sand out and sand free manure out at a controlled rate. The passive systems are a bit you would call it more uncontrolled separation because when you think of a sand settling lane 300 feet long, as soon as the first grain of sand settles, the geometry of that lane changes. And so the sand settling dynamics change. Or if someone collects the sand after 8 hours versus 4 hours, the dynamics change. And so you have a situation where sometimes the results aren't quite so predictable. Like I said, mechanical systems are purpose-built. Mining equipment, or at least they should be, because manure equipment doesn't last in sand. Passive systems or settling systems use payloaders, and that's a good thing because payloaders are simple and they're redundant and everybody can drive them. And if they break down, because you're such a good guy and you pay your bills, someone's going to bring a new payloader out to you. And so you don't really miss much of a beat. And so it's a bit more of a continuous situation in the event that you have a breakdown. The mechanical systems, it's a little bit different. It's not traditional. It's not traditional farming equipment. It's specialist type equipment that might require dealer support, might require additional spares on hand. It's just different. And then the mechanical systems will probably produce cleaner sand. Not probably. The mechanical systems will produce cleaner sand right out of the gate. Whereas with the passive systems, the sand's going to be a bit dirtier and a bit wetter, coming right directly off the lane. Um, but it can get there. It can get there to being recyclable quality, but it just needs more time to drain and condition. I want to emphasize the fact that they both can get you good results. They can both get you results 95% sand capture and higher. The bottom line is this. Which do you choose? Which one you choose should be based on what you would like to manage. Okay, that is so key. You want to have a tool that you like using. You don't want to have a tool you don't want to use or not familiar with or comfortable with. Make matters even more crazy, mechanical systems are oftentimes enhanced by passive systems, and passive systems are enhanced by mechanical systems. So there's this cross-pollination back and forth between the two. Again, just emphasizing the fact that what you choose should be based on what you would like to manage. So again, just to summarize, for both mechanical systems and sand lanes, we want to have the correct sand, we want to have the suitable water quality used at the right location, and we need to have proper management and maintenance. Just a couple other considerations. When it comes to, a lot of times dairies will be converting from a fine sand to a coarse sand, or from a fine river sand to a coarse river sand. Um, when those conversions happen, sand type is so critical that you need months. You need months to work that fine sand out of the system and beginning to integrate the coarser sand before you reach a steady state where it's only the coarser sand that's coming out of the stalls. And the other thing, and this is just going to kick us off to our next section, and that is we want to be testing this effluent to predict or estimate sand bypass. It's simple and it's inexpensive. It's done gravimetric methods with ovens and furnaces, and it's something that most good developers do right on the spot. And so, how do we deal with bypass sand? And really, again, it's inevitable. It's the sand that's not captured by the separation system, And it's going to include, it's not going to be just fine sand that you think you might be able to reuse for bedding. It's going to be like that sand chowder. It's all the same. It all settles. It all clogs tanks. And so it needs to be safely removed from tanks, but we really need to plan for it. We need to plan for these outages. So what can we do to kind of help ourselves a bit? So I want to talk about these two kind of phenomena. The one we call scour, which I call motion in the Y. I have this backwards, folks. This needs to be a correction. Scour is motion in the X direction, and settling is motion in the Y direction. In other words, up and down, left to right, side to side. So in the case of scour, we have a particle that's going to come down and settle to the tank floor, but yet we want to impart some velocity so that that particle can then be lifted back up into suspension. And then into suspension means we want to work against settling. So we want this particle moving in the Y direction. We want that particle moving upwards or off the floor so that it's not accumulating. So again, scour means getting it off the floor. Settling means getting it in suspension. Or another way to look at it is this way. So the scour again is taking it off the floor. But of course, what goes up comes down, right? And this is a turbulent system. Not everything's moving in the up direction. Not everything's moving in the down direction. Not everything's moving in the left direction. Not everything's moving in the right direction. Everything has an equal and opposite motion. And so, but in any case, we want to keep these particles moving. We want the bypass sand to be small enough that it can be got back into suspension by means of agitation. So do particles reach the tank floor in properly designed systems? Sure, they have to. But we just don't want them to stay there, right? We want them to get to the floor, and then we want them to have some velocity imparted to them so that they are moved back up into the bulk flow in the tank. There's a lot on this slide. I'd encourage you to come back and maybe look at the recording and pick off of this what you'd like. But what I did here was I just did some really basic calculations just to show the settling and scour characteristics of a corn kernel, an eighth inch corn kernel, right? Where we're going to assume kernel processed corn, eighth inch corn kernel particle with then a concrete sand size profile. And really what you find is if you can impart a velocity of about 1 3/4 feet per second, you are going to scour any bypass corn grains, and you're also going to be up somewhere up in here, and you're going to be scouring particles larger than a millimeter. And so as long as you can get good coverage, good agitation coverage, you don't have to have a crazy amount of agitation to keep these fine particles suspended. Oops. And then the last thing on bypass sand, I can't emphasize this enough, that safety is everything. Absolutely everything. We need to monitor the sand bypass so that we can predict our outages, and then we need to have a safe plan for cleaning out the bypass sand. I personally am a big fan of these Bristol robotic systems, where they put an unmanned robot into the tank and they go in and they clean them out, and without taking a tank down. It's just something to take a look at, or you have specialist firms where people are in there with some kind of all the requisite PPE so that they're in there vacuuming, sucking, whatever it takes to get the tanks clean. So, make the plans to do the clean out when you want to do it and not when you have to do it. You want to do the clean out before it's up to the height of the nozzle. You want to do it before it's to the point where the portals are clogged so much that the robot can't get in. So plan for it. the last part of success with sand betting, I want to break it down to people, contracts, and relationships. It's the soft side. It's the thing that, yeah, I think it's probably the most overlooked in a system. So when you take an anaerobic digestion system and with sand separation, there's three different models that we usually see. Um, kind of where does the sand separation system fit into the anaerobic digestion system? Well, um, the first is the dairy take responsibility for sand separation, right? So we're going to draw this imaginary line right here, right? And then the developer takes responsibility for everything downstream of sand separation, right? That's one model. The second model would be the dairy take responsibility for sand and solid separation, and then the digester developer take responsibility for just the anaerobic digestion piece. And the third model would be where the developer takes responsibility for everything. So I want you just to think for a minute, which of these do you think has is the recipe for success for an anaerobic digestion system? Okay. Just think about that for a minute. But as you think about that, I also want you to think about when it comes to this, when it comes to the digester, the anaerobic digester itself, there's a lot of systems that's part of that, right? I mean, you've got the feeding system, the heating system, the mixing system, uh, the gas cleanup system. There's so many subsystems as part of the anaerobic digestion system. The sand separation system is another subsystem to the anaerobic digestion system. Do you know any anaerobic digester developer that would want the dairy to take responsibility for, say, the gas cleanup system or the heating system or the mixing system? And nor do I. And so, so something that we see as being really key to successful sand separation systems of digesters is for the developer to take responsibility for the entire system. We're back to our systems approach, the entire system. And that system includes sand separation, just as that system includes gas cleanup, just as that system includes manure heating. Because otherwise, what happens is that if you're a developer, you don't know what you're going to get. You are going to get whatever the dairy sends you that day, and you can have the most tightly worded contract that penalizes the farm for sand bypass. But you know what? At the end of the day, like any contract, as soon as you have to exercise those things, it's all gone wrong. It's all gone wrong. So as a developer, you're better off saying, hey, we're managing the whole system because then we are going to ensure that the feedstock that we get is the feedstock that we want. So just a few takeaways as we kind of run up here on 10 minutes to the hour. And so successful strategies for successful sand separation or success for sand and anaerobic digestion. One is we need to have a systems approach. And that system approach, think of the anaerobic digestion system as property line to property line, from the road to the property line and everything in between. Because everything that goes on that property is going to affect this anaerobic digester. And if you're going to be an anaerobic digester developer that's going to say, listen, the tanks are mine and only mine, and you're responsible for everything else, get me the right manure, uh, you're going to be sorely disappointed because that's just not the way the real world works. Um, when it comes to the sand separation system, right, we're not going to rely on hope. We're not going to rely on the hope of sand not causing problems. Sand's going to cause problems. So you need to select the right system for your organization, and there is no one right system. There's several right systems, and I would encourage you to go and look and talk and see them all and get familiar with what would work for you. Bypass sand is inevitable. Plan for those, plan for the cleanouts. You can estimate the cleanouts. It's literally high school chemistry or even freshman in college chemistry, these dry matter tests and ash tests that give you really good insights of what's being passed to the digester. 4 and 5 kind of go hand in hand in that people make these systems the most successful. It is really probably the thing that's the most overlooked in that you have to have people who are dedicated to wanting to own, operate, and run these systems for them to be successful. And you really need to take responsibility for the whole system in order to kind of get the results that you want or that your performa and your investors require. So with that, Dan, I think we've got 8 minutes to go, and I'd be happy to answer any questions. I think somebody had some. I think somebody by name of Adam had some questions, and I don't think they were coming through, but I'm happy to answer any questions.
They weren't, but we did get a couple questions. So first of all, thanks for that amazing presentation. I thought it was fantastic. Austin wants to know if there's a target total solids concentration we maybe should be shooting for, either with passive or mechanical systems, to actually get good separation.
Great question. And so, it's almost quite uncanny that the amount of dilution required in that target TS, it really lines up really well with what I would consider to be the typical amount of water used in a parlor. And so, I would be looking at somewhere around that 6%, that 6% number, give or take, as being where you need to be. And again, it's a matter of breaking the viscosity so that the sand grains can settle.
And to that point, you had talked earlier about the wetness of water, essentially, and why using parlor water as that dilution water and keeping it as clean as you can, essentially, before that was important. But we see that all the time on dairies in Iowa, where if the whatever your water adding isn't clean enough, you're never going to get there. And then we have another question. Do you need a rinse sand? Is there a break-in period before it's uniform? Sort of, is sand, or does recovery of sand decrease with time? What's happening?
Fantastic question. So when you look at the ASTM C33 concrete sand, that is either a washed product, that is, it's a product that's been washed, i.e. settling, that it's a product that's been washed, and so the fines are removed from it. Or it's kind of the example that we talked about river sand, Dan. It could be a river sand that Mother Nature has washed away the fines. And so, because if you're using like a specification concrete sand, of course you're always going to lose some sand, but by and large, if you're using that right kind of sand, the sand processing process has already removed the bulk of the fines, so you don't have a really big ramp up. Now, if you were to use some kind of more of an out of spec sand, what I would call an out of spec sand that has more fines, then you're absolutely right. You would have a more of a time where you would start to wash out. You would start bypassing that sand, but once it's out. Assuming you're only topping off the lost sand with new sand. So the answer is it depends.
That's always the right answer, right? It depends.
That's the standard engineer's answer.
And then Trevor has a great question here. He'd just like you to speak to some of the difference between solid separation equipment and sand separation equipment and settling. Like, what's really the difference between those two?
Well, I'm going to say overarching, I'd say the difference between sand separation equipment and solid separation equipment is the sand separation equipment. What I would consider to be the best sand separation equipment is purpose-built mining equipment. It is equipment that is repurposed from the mining industry, being used to separate sand from manure. The colloquial term for describing that classification, that type of equipment, would be classifiers or screw washers. Every single sand and gravel pit has a version of this equipment. So for separating sand from manure, if assuming not looking at sand lines, but mechanical sand separation equipment, I would be looking at any manufacturer that is offering mining duty equipment and not manure equipment that's just beefed up. Um, Solid separation equipment, you know, uh, usually with solid separation equipment, even if you're having like a solids content of up around 6%, that's still kind of high for some solid separation equipment. Like sometimes slope screens have a bit of a challenge with that type of material that's that high of total solids just because material starts building up on the screens. In some of those cases where we have higher solids content slurries, say post sand separation, for solid separation, I kind of lean towards the rotary drum style separators. And because I think they do a better job handling a bit of a higher TS, number one. Number two, um, screen cleanliness, whether it's a rotary drum or whether it's a slope screen, screen cleanliness is key. And with rotary drums, it's a lot easier to automate screen cleaning as opposed to with slope screens. Slope screens have come miles, and there are some. I'm seeing some variations on the market now that seem to be pretty robust. Um, but typically, screen superior screen cleaning is generally found with rotary drums. But keep an eye on slope screens as well.
Perfect. And then I think our last question for the day, Paul asked, you mentioned that indigester robot. Do you have some other reputable companies, or is it still look around and sort of find one that's near you and will work for you?
Um, I'm going to mention a name only because I think it might be the only one on the scene, and it's an Iowa company, and that's Bristol. I think I mentioned them, and so that is the only one that I am familiar with, and so that is one name for you. But I would still encourage you to look around. But
Perfect.
digester, digesters clogging or building up with sand. It's funny in agriculture because digesters are semi-new to us. We think this is new, but municipalities have this same problem. Refineries have this same problem. So there's definitely specialist firms out there doing it. It's just really expensive, and dangerous to attend to. So there's people out there that would do it, but my overarching message on cleanouts is I just can't emphasize do it when you need to, not when you have, or do it when you want to, not when you need to. And so the testing is so easy, so easy.
Perfect. And that was the only robot I've found so far too. And I have reached out, but I haven't heard back about a potential webinar next season from them because I thought it was a cool little machine.
Oh, well, I'll also just give a shameless plug in that we host a podcast, and we've had them on our podcast, and they do a really nice job, and definitely would be a worthy guest.
There you go. Tune into that podcast. We'll see if we can find the episode, and I'll share that as well. And then
Yeah,
I guess this is really the last question. We got one about why people would use sand at all. So could you talk to just a few comments of why sand became the dairy
yeah,
bedding of
great.
choice?
Yeah, great question. So, real quick, traditionally, the type of bedding that people use is what was always a waste product. In New York and Wisconsin, it would be wood shaving. In California, it would be rice hulls. Parts of Texas, it would be wheat straw or something. North Dakota would be wheat straw. In Michigan, in sand, Michigan's a peninsula of sand, and so they started using sand bedding in Michigan. And what they found was milk production was about 5 to 10% higher, or excuse me, 5 to 10 pounds per cow per day higher with sand bedding because the cows were more comfortable. They stay cleaner, they show better signs of heat, and really, in a nutshell, sand is not a carbon source. So you put a boy and a girl bacteria in that sand in sand, they just do nothing. You put two bacteria family in sawdust and shavings and whatnot, and it's party time. So sand is a more hospitable environment for cows' teat ends to be resting.
Perfect. Thanks so much, Andrew. Thank you, everyone, for joining us. And hopefully, you can tune in next month for Jason Oliver from Cornell. He's going to be talking about some of the work they've been doing on how much residual methane comes from a storage after a digester. And is that storage any warmer if you're putting digester effluent in it? So hopefully that'll be an exciting topic for you all. But really appreciate you coming in today, Andrew, and sharing all the great information on sand separation.
Thank you, Daniel.
That was great.